Evaporation, and crystallization, which are all physical separation techniques to separate out mixtures back into their original form. So for example, a solution of sodium chloride in water, so salt water, we can separate it back into its original forms. So we can only use this to separate mixtures, because mixtures are not chemically bonded together, right? Mixtures are basically stuff that we can make in our house, so we can make salt water or sand water stuff in our house, right? But you can't separate out molecules or compounds using this method because molecules and compounds are physically joined together. They're chemically joined together, so we cannot separate them out. We need to do a chemical reaction to separate this in the lab. So let's look at these three physical separation techniques. So we use these techniques, and they're used to separate soluble and insoluble solids from liquids. Before we continue, let's look at some terminology. So what does soluble and insoluble mean? So sand in water, right? We have sand within the water, so it doesn't dissolve, right? Have you ever seen sand that dissolves in water? Never, right? So it's a mixture between a liquid and an insoluble solid. So the liquid, we call the liquid the solvent, the thing that the thing dissolves in. But the liquid isn't a solvent because the sand isn't dissolving in the water, so it's just a liquid and an insoluble solid. So insoluble, like you guessed, is insoluble. It cannot dissolve. On the other hand, soluble means it can dissolve. So soluble can dissolve, insoluble cannot dissolve. So because sand doesn't dissolve in water, right? It's an insoluble solid between a liquid and an insoluble solid. Sodium chloride. So sodium chloride is what we commonly call table salt. So table salt in chemical form is sodium chloride. And when you put salt in water, sodium chloride in water, it does dissolve, right? So it becomes a solution. It's only a solution when the solute dissolves in the water. So the solute is the sodium chloride. It's the thing that dissolves within the solvent, which is the water. So it's only a solute and a solvent when the solute dissolves in the solvent. So in this case, the water isn't a solvent and the sand isn't a solute because it's not dissolving. It doesn't dissolve, right? It's insoluble. However, in a soluble solution where it does dissolve, it becomes a solution because the solute did dissolve in the solvent, which is the water, and the solute is the sodium chloride, which is common table salt. So let's look at the different techniques that we use to filter out or separate these soluble and insoluble solids from liquids. So we have technique number one, which is called filtration. So filtration is obviously we can't separate out different dissolved stuff, right? Can we separate out salt water from by using filtration? The particles of salt are way too small to pass through to get caught in the filter paper, right? So filtration is used to separate insoluble solids. So it's stuff that haven't dissolved in the water yet. So the particles have to be bigger than the water particles. So for example, we can have sand from the liquid, the solvent. So sand particles are bigger than the solvent, right? We can see individual sand particles, but we can't see individual water particles. So we use filtration to separate insoluble solids, so sand, for example, from the solvent, the liquid. So we have filter paper where water can pass through, but not the solid. So the filter paper has tiny holes where water particles can pass through because it's incredibly small, right? But the sand particles or any other things like rocks can't pass through filter paper, so they get caught in the filter paper. It's kind of like when you make instant coffee using what do you call it? Coffee powder. The coffee gets stuck, the powder gets stuck, but it only allows the actual coffee drink to drain, not the different powdery stuff. So filter paper filters out the stuff that are bigger than the liquid, the solvent. And the filter funnel, we put the filter paper, my lovely drawing of a filter paper here, within the filter funnel that allows the water to just come out and get stored within the beaker that's stored beneath the filter funnel. So this is used to separate insoluble solids from liquids. However, if you have a soluble solid that has dissolved in a solvent, forming a solution, right? A solution is only when it has dissolved, when the solvent has dissolved, when the solute has dissolved, right? So when we have a solute that has dissolved in the solvent, for example, water, forming a solution, we have two choices we can make. We can either use evaporation or crystallization. So evaporation is when it's a quick and easy way to separate out solids from a solution. So it's a quick way to separate out, for example, salt from a solution. However, some solids decompose when heated. So decompose is when things break down. So some solids actually break down and they change. They get broken down into a different chemical or different something else. So when they're heated and when they break down, they form something new. So we can't use evaporation for all techniques, but for stuff that can work, we can use evaporation because evaporation is much easier and simpler than crystallization, which we will look next. But anyways, some solids decompose when heated, so it's called thermal decomposition. So when they're heated, they break down into something else. So evaporation is a quick and easy way to separate solids from a solution. Evaporation is basically what you just think of when you hear the word evaporation. It's like when you have a cup of water out in the sun for like days, it's gonna all evaporate off. And if you have a cup of salt water, it's the solvent is gonna all evaporate off, and you're just gonna be left with salt crystals, right? That's exactly what evaporation is, but we're just gonna speed up the process a bit faster by heating it up to a higher temperature by using a Bunsen burner. So the Bunsen burner is stored below the tripod, and on top of on the tripod, we have an evaporating dish. Within the evaporating dish, we put the solvent. So in this case, this could be salt water, seawater. So we covered it's sodium chloride, right? Sodium chloride is salt. Table salt is sodium chloride and water. So the solution will be in the evaporating dish, and when it's heated, the solute is gonna I can't speak. The solvent is going to evaporate off, right? So the liquid is going to evaporate off, leaving just the solute. So it evaporates off, leaving salt crystals that you can separate out. So all the solvent has dried off. Now, this only works for stuff that does not get affected by thermal decomposition, right? So what do we do for stuff with thermal decomposition? We use a process called crystallization. Sounds cool, right? It's a lot harder though. Let's look at crystallization. So technique number 3 to separate out mixtures is crystallization. So it's a much slower technique than evaporation, and it requires a lot more things to be done. So it's used for solids that have dissolved, making a solution, so just like evaporation, but it's more specifically used for stuff that are susceptible to thermal decomposition. So we could use this for things that are not susceptible to thermal decomposition, so for example salt water, but we wouldn't generally use this technique because this technique is much slower and it requires a lot more time and effort. So we'd rather just use evaporation, which is much faster. Now, the reason this is so slow is because rather than heating it up with a Bunsen burner, so a Bunsen burner is hot, right? So it heats up fast and evaporates this water quickly. However, we use a water bath instead. So a water bath is when we have warm water and we have the solutions. We slowly dry out the solvent. So this is going to be much slower, right? Because you're not directly heating the solution. However, this allows it to provide a gentle heating by using a water bath. So this allows to reduce the effect of thermal decomposition. So the things that are susceptible to thermal decomposition, the heat, they won't break down because it's being heated really gently through a water bath. So it's basically the same kind of equipment as heating it up with a Bunsen burner. So you have a tripod holding the evaporating dish with the solution within it, but we're going to use a Bunsen burner to heat it up instead. So we're going to put the tripod within the water bath and a solution within it. And by the way, this drawing looks like the water in the water bath is inside the solution. So it's just this container is being put into the water bath. The water in the water bath isn't actually entering the solution. So once it's slowly heated like that, some of the solution is going to dry out, right? And slowly crystals are going to start to be formed because as the water dries out, there's going to be less, it's going to be less soluble. Soluble is like less dissolvable. It's less likely to dissolve. So the salt crystals, it'll be less likely to dissolve. So if you leave it to cool, so solids are less soluble at cooler temperatures. So when it's kind of why like when you heat up salt and water, the salt dissolves faster. So when it's cooler, the solids are less likely to be soluble. So you get rid of some of the liquid by using a water bath, and then you leave it to cool. And then you filter out the crystals from the water by using a filter paper. This is just like filtration. That leaves just the salt crystals, right? And the remaining water just goes out. And just heat it through a sun. If you're in the sun, so you could heat it up through the sun, just leaving it outside. If it's winter and it's quite cold, you could just put it in the oven and heat it that way. And that just now you only have the salt crystals, so you're just heating up the salt crystals to dry out the crystals and to just get pure crystals. So these are the three methods of separating out mixtures: crystallization, filtration, and evaporation. In coming videos, we'll look at chromatography as well to separate out different colors of inks. But these are just the three common separation techniques for common mixtures. Thanks for watching this one.